Hi, I'm Phil Spear. Myself, Colin, and my esteemed team, we developed the game here as Immortals, and we are the Red Dead Squirrels. So next slide, please. Who are the Red Dead Squirrels? Well, we're awesome. I'm Phil Spear. I did motion capture and general game mechanics. Colin Baker was the other team leader and did scripting. Trey Spears did networking and scripting. Luke Gomez worked in the user interface. Daniel Robeson and Devin Poole were our own in-team art and level design department. Justin Garrett worked on scripting and also networking, and Stephen Killingsworth just kind of helped out with a bit of everything, but especially also focused on the scripting and networking aspect. So to tell you a little bit about the game, the base design that we were going off of, Trey's going to come up and do that.
Right. Immortal. It is a gladiator type game with a kind of twisted metal spin. If you ever played that on PlayStation systems. It's set in a different universe where there's a curse on the land, and everyone who was alive during the curse can no longer die. Their bodies are aged, so they have skeletons, zombie bodies, whatnot. And what happens in this world is there's this mysterious girl. No one knows who she is. She appears once every few hundred years or so, and she holds this thing called the Immortal Games. And the winner of the games gets their wish granted. So similar to Twisted Metal in that you have people fighting in a gladiator kind of combat, and if they win, they get their wish granted, but their wish never gets, it's never really what they wanted. So we don't have like a story in the game, that's the premise of how this was supposed to be set up. We have 3 player classes that you can choose. First is a rogue, her name is Geist. She's like a zombie kind of body type. She has a crossbow, she can shoot grenades, she has one melee move she can do. She's faster than all the other pawns, and she has less health though. So she's faster and quicker, her stuff does pretty good damage, but the drawback is she doesn't have a lot of health. One of the other player classes is the mage, Coel, or Lich. He is also similar to the mage, the rogue, in which he's mostly range, but he isn't as mobile. His attacks do more damage, and he has a little bit more health. So he's kind of like, when I explain the warrior, he's kind of like a mixture of the warrior and the rogue, in that he can do a lot of damage, has about as much health as the warrior, but isn't as mobile as the rogue. The warrior, Ignis, he's almost purely melee. He has a charge ability, it's pretty cool. He's based off of the skeleton warrior, has like really cool armor on. When the artists show you, you'll see what I mean. Basically what happens is they all have their reasons for wanting to fight in the games and have their wish granted. And like in the game we're in now, we don't have like you win, like you just keep fighting for a long time, forever, until you quit. But what was planned was if you were to get killed, then you would lose, and the person would win. And his little story section about how his wish got granted would show that, and obviously it would not turn out how he expected. So that was basically the idea behind Immortal. We had a lot of fun making it, and to go into more of the theory about the combat, I'm going to hand it over to Philip.
We started off with 3 more or less distinct, unique character design systems, strong in their own aspect. The original idea for the combat was that you have an Xbox 360 controller with 4 face buttons, and each one of those 4 face buttons was tied to one specific style of move that character could do. The movesets were initially fairly unique. As we got further into the game, I decided to move to a more of a complex, more of a cinematic fighting style where it was more action-based and things where you'd have to react more carefully to your opponent's moves rather than just being a standard slugfest. Eventually, we compromised on a more complex than the original 4 buttons, but certainly not as cinematic and action-packed as we originally started due to both time and thematic constraints. It just didn't really seem to fit with how we had originally gone with the game. So now what we've done is more of a button combo system where you can type in a series of commands and then you can push one final button to execute them. So you can queue up 3 attacks, either different types or even of the same type if you want it to be more powerful, and then go ahead and do that one in a unique animation and whatever effect will play. from the original document, I boiled down the 4 types of attacks into a knockdown, a knockback, a stun, and a secondary. The secondary attack was if you were primarily a melee character, you would do a ranged attack, and if you were primarily a ranged character, you would do a melee attack. Whereas the other 3 are pretty self-explanatory in that their name describes exactly what they do. So using all 4 of these types of buttons along with a standard primary attack, you could go ahead and throw different aspects of whatever attack you wanted to do into your offense. If you wanted to focus on making sure the opponent couldn't run away, you could throw in a lot of stuns and maybe a knockdown. Or if you wanted to go ahead and mix it up a little bit as the warrior, you could step back and throw in some secondaries. So now that most of the design had been finalized, they'll implement that percent over to our scripters, which were Justin, Colin, and Trey. They're going to talk to you about how.
Okay, so I'm Colin, and the first thing I decided to work on was, as Phil was mentioning, the combo system. And I first thought that the combo system would be rather difficult to implement, given that it would have to detect buttons and know which combos to do. But as I was looking into what the UDK had to offer, I saw that it had state machines. You could switch between states automatically. You didn't have to actually build the state machine. You just had to mention what state you wanted and what state you wanted to start in. So first there's you start off in this normal state, which when you push the buttons, it does whatever attack it would normally do. And when you hold down the combo button, it switches your state to the combo state, which when you push a button, all it will do is add a character representation of that button onto a string. And when you release the button, it sends it into a switch statement, which compares all of the different various combinations. So it checks to see if what you entered is a valid combination. And then it will execute the function that's inside of that switch statement. So with that, the framework of the combo system done, then we had to turn to getting melee working because we had a warrior. And unlike the others, he actually had to have melee working, which wasn't directly supported in the UDK, which Justin will talk about.
Hi, Colin. My name is Justin. I was in charge of the 3 weapons, the sword, the crossbow, and the staff. The sword was the most different from what the UDK is used to, seeing that it is used to ranged weapons. So getting the melee weapon was quite difficult to work. First, the problem that we had was attachment. The way attachment happens in the UDK is attached to the skeletal mesh of the weapon and the pawn is a bone, and attached to the bone, you have sockets. Well, first we had weapons with no bones, and we had meshes with no bones. And then after we finally got the bones, it turns out the sockets have to be named certain things from the pawns. For the right hand, the pawn has to be called weapon pawn. For the left hand, it has to be called dual point. Once that was figured out, we had to figure out how to get the weapons spawn in the right place, because they're either spawn behind our character, upside down, or in our body somewhere. So that was just a simple pivot translation through the script. The final problem that we had with the sword was tracing. At first we decided that we were going to shoot an invisible bullet, and then Colin later found a tracing algorithm that would trace between the hilt of the sword and the tip of the sword. Well, after about a month and a half of trying to get that to work, we figured out that the tracing was putting the tip of the sword and the hilt of the sword on the floor for some reason. So that was just a few more connecting issues, which was resolved pretty quickly. And then it wasn't swinging at all either. So I figured out that the pivot world translation rotation socket function would actually attach it to the sword and not to the floor, which allowed us to do the damage finally. The problem with that is the trace is so small that it gives us problems with networking and stuff.
So melee combat is not very nice on network. And so tracing example, we tried to get the server to tell, the server knew about the weapon, the client didn't know about the weapon. And then the client didn't know about, the server didn't know about the position of what the weapon was in the world. So, because the client was the one that was calling that function to tell the server that, the client didn't know what it was. So, Colin decided that we should try to attach a sphere to the tip of the sword instead of tracing a line through the sword. We tried that, didn't work. It worked on single player, but on working on multiplayer, it still didn't see anything. So after much trial and tribulation, I decided to go back to the original idea that we had, which was just to shoot an invisible particle in front of the character so far, and just despawn it after a certain length of time, and have that work with the server. And the thing that's nice about it is UDK, like they mentioned, is built in with projectiles in mind. It has guns, it's all guns. So their server application for that, for the most part, worked pretty well with the sword. I just had to change just a little bit of stuff. So going into from the melee to just the network in general, networking in the UK is just it's not as easy as we first think it would be. Like, for example, we had three ideas for a game, three different ideas for games. We had Immortals, and then some other games that wouldn't have been on the network, but they were a little bit more complicated in the implementation. So we were like, oh, let's try to see how networking is handled in UK, and if it's not too bad, we'll go to Immortals. So the first few weeks we were connecting to the servers, like, oh yeah, this is easy, this is really good. We were shooting each other with guns and whatnot. And so we switched it, we were like, all right, Immortal. And then once we got to the melee stuff, we were just like, oh my god, networking is just not working. Like, it's just ridiculous. So I took it under my wing to go and just like go crazy for a week probably in the lab, just to look at specifically how replication works without the UK structure. The interesting thing is that certain classes will only work on the client, while certain other classes only work on the server. And in some cases, they don't. Some cases, like the server can't even talk to that specific client, and that client can't talk to that specific server class of it. So, for example, the HUD can't interact with the server. The only way the HUD can interact with the server is if it interacts with its controller, which then can interact with the server. So, the problem with the melee was that we had the pawn which was holding the sword, which was owned by a controller. The pawn was a simulated proxy, meaning that the server knew where all the pawns were, and they were being simulated on the clients by some kind of, they send their position like Ross had said earlier, and give you like the velocity of which direction they were going in at certain points in time, so you wouldn't have to like be constantly sending that information. And so the servers knew where the pawns were, like 100%. The clients had an idea where the pawns were. The controller was telling the pawn to attach a sword, and the controller wasn't the client. So it's just, basically this picture sums it up. It's just a divine explosion. So networking was a pain, it works sometimes, and the biggest thing about networking is sacrifice. So we would get things working really well in single player. And then we would, this was how you probably do in the future, is actually start building it from the ground up to work on multiplayer. We had it work in single player, and then we're like, okay, let's move everything to multiplayer. And it worked. But the cool thing about networking is, at least the UK handles it. It's not, it's pretty concise. You don't have too much like rubber banding. Like people show up where they should be from client to client, and you don't have to miss. It's not as nitty-gritty as you probably have to do it in Ogre, for example. So UK gives you a lot of stuff. It's just figuring out how through their spider web of how everything attaches, how to get things to talk to each other. So that's pretty much networking in a nutshell. Philip did motion capture, so I'm going to hand it over to him. He can tell you a little about that.